All right, so we are going to finish up 2.5. We were proving these trig derivatives. So if we look at this one, we're going to show that the derivative of cosine of x is negative sine of x. So the derivative of cosine of x, using the limit definition, we'd have the limit as h approaches 0 of cosine of what, x plus h minus cosine of x all over h, right? And then we have that cosine sum, right, that we've got to expand.
Yeah.
So expanding that cosine sum, we would have cosine of x, cosine of h, minus sine of x, sine of h, minus cosine of x. All of this is over h. Okay, excuse me. And then just like we did up in the one where we were proving sine of x, if you look for something that you could combine and maybe factor something out, I notice a cosine here and a cosine here, right? And so if I were to put those together, I could factor out a cosine of x, right? So that would give me the limit as h approaches 0. I'm going to factor out that cosine of x, and that's going to leave me with cosine of h minus 1, and then I still have that minus sine of x, sine of h, all over h. And then we have two terms there, don't we? That we could separate out. And so you can see that the limit as h approaches 0 of cosine of x times cosine of h minus 1 all over h minus sine, man, got a tickle in my throat, sine of x, sine of h all over h. And then we've got some limit identities, right? So the limit as x approaches 0 of these is what? 0. And the limit as x approaches this, or as h approaches this, is 1. Correct? Mm-hmm. And so here you're going to have cosine of x minus sine of x times 0. So cosine of x times 0 minus sine of x times 1 would just give me the derivative of cosine of x equals negative sine of x. So you can see where those come from using that limit derivative, or that limit definition. So the derivative of sine of x we know was cosine of x, and the derivative of cosine of x is negative sine of x. All right. Looking at derivatives of natural logarithms and exponential functions. The derivative of e to the x is the only function that is itself, it's itself for the derivative. So the derivative of e to the x is simply e to the x. Yeah. Now, this one is one that you guys will have to make sure you know. If f of x is ln of x, then the derivative of f of x is 1 over x. Now you have to remember your logarithm laws, your laws of logarithms. So remember, when you have an exponent, you can take it down in front, right? And when they're multiplied, you can separate them with addition. And when they're divided, you can separate them with subtraction. All right, so looking at this one, I'm going to rewrite this as, what, 3 ln of x. Yes? So then the derivative of f of x, we still have the 3, right? The derivative of ln is 1 over x. So the derivative of f of x would just be 3 over x. For g of x, I need to start by separating these out. That would give me ln of x squared plus ln of e to the x. Well, I still need to rewrite these. This one would be 2 ln of x. But what about ln of e to the x? What is that?
That is 1.
Remember, log base e of e would be 1 because of the exponent's 1.
Yeah.
But in this case, it's going to be
X.
x. You could have also brought that x down in front and said ln of e is 1, right? You'd still get x. And then we do the derivative of each term, don't we? So here, I wrote the derivative there, and that's not the derivative. That's just still the function. My bad. I just rewrote the function there, right? Now I'm going to do the derivative. So here, the derivative of ln is 1 over x. So I've got 2 times 1 over x. And the derivative of x is just 1. Correct? So then the derivative of g of x is 2 over x plus 1. We good there? Okay, looking at h. Here, I'm going to need to rewrite this because of that x in the denominator. So my function is ln of x minus x to the negative 1, isn't it?
Mm-hmm.
So then now I can do my derivative. The derivative of ln of x is 1 over x minus the derivative of x to the negative 1. Well, I bring that negative 1 down, and I would get x to the negative 2, correct? Because I have to subtract 1. So then simplifying there, h prime of x, the derivative of h of x, is 1 over x plus 1 over x squared. What if this was written as x plus 1 over x squared? Is that the same thing?
Yeah.
It is, right? It's just combined. So you need to be able to recognize that, hey, those are the same. Looking at D, we got some doing here, don't we? So the first thing I know, I can rewrite this function as ln of 2e to the x minus ln of 3 to the x. 3 times x, right? But then those are multiplied, so I can separate them still, can't I? So then here, when I separate those, I would have ln of 2 plus ln of e to the x minus ln of 3, and I would subtract ln of x, since that was both being divided, right? Now, here, I can even go further on that one, can't I? Derivative of y, not derivative, sorry, the function, still not going to do the derivative yet because ln of e to the x is just x, isn't it? Then I have minus ln of 3 and minus ln of x. Now I can do my derivative, yes? So doing my derivative now, what is ln of 2 is a constant, isn't it?
Mm-hmm.
And what is the derivative of a constant?
Yeah, 0.
Yep. Slope of that line is 0, right? All right, how about x?
1.
All right, and ln of 3?
0.
And ln of x?
1.
1 over x, right?
Yeah.
So then the derivative, or y prime, would be 1 minus 1 over x. It also could have been written as, what, x minus 1 over x? I'm just saying that because on a multiple choice, you need to be able to recognize that those are the same thing, right? All right, we're getting to the end here. Looking at E. We got a lot of separating to do there.
Mm-hmm.
So here, f of x would equal, they're all being multiplied, so I'm going to separate them all with addition. Do you agree?
Yep.
And then I can do a little bit of cleanup there. My function would be ln of 4 plus 3 ln of x plus x. Now I can actually do the derivative. I can derive this. Ln of 4, the derivative would be
0.
3 ln of x, the derivative would be 3 times 1 over x, and the derivative of x is just 1.
Mm-hmm.
So the derivative of the function would be 3 over x plus 1.
Or
Yeah, you could all,
plus x over x.
you said 3 plus x over x. Yep, that would be the same thing in different form. Yep. Okay, looking at g of x, we just need to really work with that part right there, right? To rewrite it. So I would rewrite this as pi e to the x minus, what, x to the negative 2/3? Do you agree?
Mm-hmm.
Okay. Well, when we do the derivative, pi is a constant, so we know that's still going to be pi, right? Times e to the x. Well, the derivative of e to the x is still e to the x, isn't it? It's that one function that it remains the same. So pi e to the x is going to stay pi e to the x. But then here I bring down my negative 2/3 and I subtract 1, so I'm subtracting 3/3. So that'd give me negative 5/3, wouldn't it? So the derivative of g to the x is pi e to the x plus 2 over 3x to the 5/3. Or you might also have seen it written as pi e to the x plus 2 over 3, and it could be cubed root of x to the 5th. Or you could have had 3x cubed root of x squared, right? There's several different ways that could have been written, but this is an absolutely appropriate answer. So if I was doing a free response, I would stop right there because I don't need to go any further and I don't want to chance making some dumb algebraic mistake, right?
Yeah.
But if I'm looking for an answer on multiple choice, I may need to manipulate a little bit, right?
Yep.
Make sense?
Mm-hmm.
Questions? All right.